Hello, my name is Taylor Ross. I'm the owner of Frustum Virtual in Los Angeles, California. In this tutorial, I'll be showing you how to set up the anti-latency FreeD server. This is a console application that allows you to transmit tracking data from anti-latency devices using the FreeD protocol. In order to get the FreeD server, you need to navigate to antilatency.com. Look for the Developers tab in the upper right-hand corner and select it. Next, find this green circle in the upper left-hand corner and select it. Then find the Software tab and open that. Once you're on the software page, look for the Anti-Latency FreeD server. Go ahead and select that. This Anti-Latency FreeD documentation covers all of the information that I'm about to go over. There will be a link in the description if you feel like following it from the documentation, or you can just continue to watch this video to learn everything that's covered in this documentation. First thing you'll need to do is download the Anti-Latency FreeD server. In order to run the Anti-Latency FreeD server, you'll need the anti-latency service with the same version number. I covered the basic overview of anti-latency service in another tutorial, but I will quickly open my anti-latency service to show you that I am running the release 4.2.0. Once you select the FreeD server that matches your anti-latency service, you'll select Download. By default, this will download into the Downloads folder of your computer. Once it's downloaded, navigate to your Downloads folder, find the Anti-Latency FreeD server 4.2.1, right-click on it and select Extract All. I've placed this extracted folder on my desktop so that I have easier access to it. Here's my Anti-Latency FreeD server folder. I'll go ahead and open that. I'll open Windows Desktop, x64. Now I'm going to find the JSON file labeled Settings. I'm going to right-click on this, select Open with Notepad. You can open this JSON file with any text editor. I just have Notepad. So now I'll just cover all of the settings starting from the top. We have server settings. The first setting that we see under server settings is the IP. This is the IP address of the device the tracking data will be sent to. The default value is 127.0.0.1. If you leave the IP address set to this default value, the data is sent to the same device where the utility is running. You can write an IP address of another device inside the network instead of this value. I've gone ahead and input the IP address of the system that I want to receive this FreeD camera tracking data. When you are running the FreeD server for camera tracking data in Unreal Engine or Aximmetry, you will need to input this IP address as well as the port number. The next setting we have is port. The port number is a port of the device that will collect the tracking data. The default value of 40,000 is the default port in Unreal Engine. You can also copy the port number from the application you're using. This default value works in Aximmetry as well. You will just have to specify this port number when you're setting up the FreeD settings in Aximmetry. I will show you how to use the FreeD server in Aximmetry and Unreal Engine in separate tutorials. For this tutorial, I'm just showing you the setup of the FreeD server settings. The next setting we see is send rate. This is the frequency of sending data packets per second. You can set the value higher than 100 if your application can receive and process that many packets per second. I'm not going to change this send rate setting for this tutorial. The next setting we see is broadcast. This parameter will specify data addressing to one device or all devices inside the network. The default value is false. This is a unicast mode. Unicast mode means that the data will only be sent to one device. The true value paired with the IP ending in 255 is used for the broadcasting mode. The X's represented here are the first 3 octets of the network the tracking data should be sent to. For example, an IP address of 192.168.0.255 is used to send data to all devices in the 192.168.0.0/24 network. Now that we've covered all of the server settings, we'll go into the tracker settings. By default, you have tracker settings for 2 cameras, camera 0 and camera 1. The first setting we see is the camera ID. The camera ID should be specified as an integer from 0 to 255. You'll want to make sure that the camera's ID for each tracker is unique. Next, we have the socket tag. The socket's tag is the tag that is attached to the selected camera. These tag properties can be set in the anti-latency service. To set this setting, I will open my anti-latency service. I will then navigate to the device network. The anti-latency socket and alt will populate under this root property once it's connected to your computer. Now that my socket and alt are connected to my computer, I will select the anti-latency VP socket. At the bottom of these properties, you will see a tag. I've already labeled mine as camera 0 to match the socket tag from my FreeD server. You just need to make sure that this socket tag property matches in anti-latency service and in the JSON file that will be running for the FreeD server. By default, this tag property will be blank. Once you update this tag property to match your JSON file, you will see that anti-latency service says a new value is scheduled for applying. Select the pen in the lower right-hand corner and then select Send Settings to Device. Since my tag in anti-latency service was already labeled camera 0, I'm not going to send any settings to the device. The next setting we have is placement code. The placement code is referencing the placement from anti-latency service. We will navigate to the Placements tab at the top of Anti-Latency Service. Now I will select the 3 dots under Identity Forward Inverted. In this drop-down menu, I will find Copy Link and select it. Now back in our JSON file, between the quotation marks, I will use Ctrl-V to paste. I will then make our text document full screen so that we can see the code that we pasted. We will only need the section of this code that is highlighted in red. So I will go ahead and delete everything except for this red highlighted area. Make sure not to delete the quotation marks. And then here at the end, we will need to delete this as well. We just want to make sure that we're removing the excess information, leaving only the placement code. This placement code is the alt's position relative to the pivot point of the camera. If the value is empty, the default placement in anti-latency service will be used. So if I come back to anti-latency service and select the 3 dots, I can select Set as Default. This will use the Identity Forward Inverted as my default placement. The default placement is also represented by this blue checkmark in the upper right-hand corner. Just remember that if the placement code in the JSON file is left blank, it will reference the default placement from anti-latency service. So just to be clear, you're only keeping this section of the code. Now moving on to the environment code settings, we will navigate to the Environments tab of Anti-Latency Service. I will select the 3 dots next to Pillars Tutorial, find Copy Link and select it. And just like with our placement code, we're going to paste this into our JSON file between the quotation marks. Now we only want to keep this section that's highlighted in red. So I will select everything on the front end up to the equal sign and delete it. And then I will do the same on the back end, everything from and name. Go ahead and delete that as well. The environment code will reference the IR layout of the tracking area in anti-latency service. If the value is left empty, the default environment in anti-latency service will be used. I'm just going to go ahead and select this environment code and delete it. And again, just to be clear, this is all that will be kept. You will delete everything else. Now I will quickly explain the extrapolation time. The extrapolation time setting is measured in seconds. A positive value in extrapolation is into the future. A negative one is into the past. The more this value differs from 0, the less reliable the extrapolation result will be. In most cases, a value of 0, 0 or a negative value is used, since the tracking data stream is usually ahead of the camera video stream. You can find the optimal extrapolation time during your tests. If the recipient program has a tracking/video delay setting, then you can use extrapolation time 0, 0 and adjust the delay in the recipient program. For example, in Aximmetry and Unreal Engine, there is a tracking and video delay setting, so you can just leave this setting at 0 and adjust it in those programs. Now I'm going to navigate back to the device network in my anti-latency service. The last thing I want to show you is what a 2-camera setup would look like with 2 sockets and 2 alts attached to anti-latency service. You can see that my anti-latency VP socket, the tag is labeled as camera 0. Now when I connect a second socket and alt, I will navigate to this newly connected socket properties, find the tag. You'll see that it's labeled device 0. You'll see that my JSON file properties have my second camera labeled as camera 1, so I'll copy that. And then I will paste it into the tag properties of the second alt. A new value is scheduled for applying, so I'll select the pin in the lower right-hand corner, and then I'll select Send Settings to Device. Now the last thing that we need to do for a 2-camera shoot is make sure that our placement codes are correct. In anti-latency service, we'll navigate to the Placements tab. My first camera is using Identity Forward Inverted, so I will select the 3 dots and then select Copy Link. In Device Network, this placement corresponds with the alt labeled Camera 0. So in my notepad, I will find Camera 0, paste this link. Once we paste the link, we will need to remove the extra information. This is everything up to the equal sign and then everything after and name. We just want to make sure that we only have the placement code in this placement code setting. We will now repeat this process for the second camera. I'll navigate back to Anti-Latency Service, navigate back to the Placements tab at the top. My second camera, or the camera with the tag Camera 1, will be using Identity. So just like before, I will select the three dots, select Copy Link. Now back in my notepad, I will paste this into the placement for Camera 1. And just like before, we will remove all of the extra information, everything up to the equal sign, and then everything after and name. When doing a multi-camera shoot, we need to specify the placement of each alt on each camera. If the value is left empty, the default placement in anti-latency will be used. In a two-camera shoot, leaving the placement codes blank will not work because both devices will be referencing the same placement code. In another tutorial, I will cover placement in more depth. Once we're happy with all of our settings, we can go ahead and save and then close the notepad. Reopen this folder. Navigate to my anti-latency server, FreeD server. The type application, we'll just open that. Now you can see that the anti-latency server is running. We have two devices connected. So this is what it should look like when it's actually running. In another tutorial, I will cover how to use this in Aximmetry and Unreal Engine. You should now have a pretty good understanding of all of the JSON file settings for the FreeD server from anti-latency. Hopefully this video was helpful in getting you started with the anti-latency FreeD server. Be sure to like and subscribe for more videos, and thanks for watching.